Alrighty, this is going to be a little bit different today, as you might guess, because this is a viewer request. By viewer request, I was asked to read through and review this particular article from Scientific American. It's time to engineer the sky. So this is a viewer request special. Let's go. So, of course, by request, the time to engineer the sky here came to my attention by a viewer, and so I figured I might as well give it a read through and have a look at it. So, what this refers to, this article primarily refers to, is talking about a concept called geoengineering. And the idea with geoengineering is to basically, comes up quite often in the context of climate change. Basically, the idea is, let's do things to alter the amount of solar radiation coming into the atmosphere in order to basically reduce the amount of warming that could happen. Basically, as a way to counterbalance the input of greenhouse gases. Now, this is interesting to me in two things, because it is an artificial engineering of the atmosphere. Let me just grab a proper definition here so I have it in front of me. One moment. So geoengineering is, in essence, geoengineering is the large-scale manipulation of a specific process central to controlling Earth's climate for the purpose of attaining a specific benefits. Global climate is controlled by the amount of solar radiation received by Earth and also by the fate of this energy within the Earth system. That is, how much energy is absorbed by the Earth's surface and how much is reflected or radiated back to space. The reflectance of solar radiation is controlled by several mechanisms, including Earth's surface albedo, which is essentially its reflectivity, and cloud coverage, and the presence in the atmosphere of greenhouse gases such as carbon dioxide. If geoengineering proposals are to influence global climate in any meaningful way, they must intentionally alter the relative influence of one of these controlling mechanisms. So, basic physics here with the climate. If you've been in a weather class or a climate-related class, or perhaps even a high school physics course might teach this, physics or environmental science related course might teach us, you have incident solar radiation. Some of that is reflected back to space. Some of that makes it through to the Earth's surface. The Earth's surface then reabsorbs and re-radiates that heat. Now, what's the difference? Infrared radiation coming in from the sun is shortwave radiation. Solar radiation is a short wavelength. And our atmosphere is, for the most part, transparent to that. But it is much less transparent to the long-wave radiation or infrared radiation that is re-radiated by the Earth's surface. And this is actually the trick that allows for life to exist on Earth to begin with, is the notion that that essentially the atmosphere catches and absorbs some of that infrared heat that is re-radiated by the Earth's surface and keeps it trapped close to the Earth's surface. And a lot of what does this is greenhouse gases. Actually, what we would know is greenhouse gases today. Some of that makes it back out to space. Some of that's just reflected back to the Earth's surface. And likewise with clouds, which are not technically speaking greenhouse gases in here, but can be reflective, can also absorb a little bit of heat and what have you. Basic premise being that energy in roughly equal to energy out, then the atmosphere is not warming. But more greenhouse gases you add, the more heat is being retained by the Earth's surface. On the contrary, the other side of that is, if there is more reflection of solar radiation away from Earth, then you would have less to go into the system to heat things to begin with, and things would be, shall we say, cooler. And that is a lot of the premise with geoengineering, and the primary focus of geoengineering has been not necessarily reducing greenhouse gases, but blocking incoming sunlight. And it raises a huge amount of logistics problems, of geopolitical problems, and the like, because Basically, the question boils down to if you implement a geoengineering scheme, which by its very nature is a global scheme, you cannot just have it be over one country over another. With this, you run into the issue of who is it amongst the nations that controls the thermostat, essentially, and how do you control it? Because you got to figure out how much and what have you. And if some kind of catastrophic thing happens that you cannot continue to run said geoengineering scheme, what happens to the planet after that? So there's those kinds of questions that come up immediately when you're talking about this. But here is the issue in question. On the crisp afternoon of February 12th, 2023, two men parked a Winnebago by a field outside Reno, Nevada. They lit a portable grill and barbecued a fist-sized mound of yellow-powdered sulfur, creating a steady stream of colorless sulfur dioxide gas. Rotten egg fumes permeated the air as they used a shop vac to pump the gas into a balloon about the diameter of a beach umbrella. Then they added enough helium to take the balloon to take it aloft, attached a camera and a GPS sensor, and released it into the sky. They tracked the balloon for the next several hours as it rose into the stratosphere and drifted far to the southwest, crossing over the Sierra Nevada mountains before popping and releasing its gaseous contents. The contraption plummeted into a cow pasture near Stockton, California. The balloon released only a few grams of SO2, sulfur dioxide, but the act was a brazen demonstration of something long considered taboo, injecting gases into the stratosphere to try to slow global warming. Once released, SO2 reacts with water vapor to form droplets that become suspended in the air, a type of aerosol, and acting as tiny mirrors reflecting incoming sunlight back to space. Luke Eisman and Andrew Song, founders of a solar geoengineering company, Make Sunsets, had sold cooling credits to companies and individuals. A $10 purchase would fund the release of a gram of SO2, which they said would offset warming effects of a metric ton of atmospheric carbon dioxide for a year. A gram of SO2 doing that. I find that dubious, to be honest. I find that dubious. They had planned to launch in Mexico, but switched to the US after the Mexican government forbade them. Many people recoil at the notion of solar geoengineering, or solar radiation management, as it's often called. The idea that humans should try to fix the atmosphere they've messed up by messing with it seems fraught with peril, an act of Faustian arrogance certain to backfire. But as it becomes clear that humans are unlikely to reduce emissions quickly enough to keep global warming below 1.5 Celsius, some scientists say SRM might be less scary than allowing warming to continue unabated. Proposals for cooling the planet are becoming more concrete even as the debate over them grows increasingly rancorous. And this is actually where the problem comes in. Who controls the thermostat? This is where it shifts very much from being a scientific related problem to a geopolitical issue. And that is actually what, as I'm reading this article, seems to be more of the issue. They're not getting into the science of geoengineering, and the reason for that is that a lot of that actually kind of makes a lot of sense. What they're talking about with sulfur dioxide becoming converted into aerosols and things like that is actually pretty well known kind of thing, because you think about volcanic eruptions. In fact, they get into it here. SRM replicates a natural phenomenon created by large volcanic eruptions. When Mount Pinatubo erupted in the Philippines in 1991, it blasted 20 million tons of SO2 into the stratosphere, creating an aerosol parasol that cooled the planet about 0.5 degrees Celsius over the next year or so before the droplets settled back to Earth. Studies suggest that if SRM were deployed at sufficient scale, maybe 1/4 of a Pinatubo eruption every year, enough to block 1 to 2% of sunlight, it could slow warming and even cool the planet a bit. Its effects would be felt within months, and it would cost only a few $1 billion annually. In comparison, transitioning away from fossil fuels is expected to take decades, and the CO2 emitted until then could make warming worse. Using machines to remove billions of tons of CO2 from the skies, a process called direct air capture, could slow warming but would be fighting itself. The machines might increase the world's energy consumption by 25%, potentially creating more greenhouse gas emissions. Because SRM can produce effects quickly, it has political appeal. It's quote, the only thing political leaders can do that would have a discernible influence on temperature within their term in office, says Ken Caldera, climate scientist at the Carnegie Institute for Science, who is also senior scientist at Breakthrough Energy, an organization founded by Bill Gates. Now, um, that's what they're talking about with this. The notion of aerosols being a reflective, where they tend to mess with the solar radiation budget of Earth is aerosols actually reflect sunlight back to space. So therefore, it doesn't end up coming down to the Earth's surface. Sunlight doesn't get absorbed or irradiated as infrared energy, and that whole process gets stopped pretty dead. And that's what they're talking about here. But what kind of gets ignored with all of this is you're talking about sulfur dioxide, and sulfur dioxide is not in itself entirely a good thing. It is good as an aerosol, don't get me wrong. High up in the atmosphere, it is good as an aerosol. But it is not necessarily good when it falls back to Earth. I'm just trying to think, what is the... Where is it? Yeah, that's what I thought. I couldn't remember, but does anybody remember acid rain? One of the things that is actually connected with acid rain is actually sulfur dioxide. And acid rain is pretty nasty. Acid rain or acid deposition is a broad term that includes any form of precipitation with acidic components such as sulfuric or nitric acid that fall to the ground from the atmosphere in wet or dry forms. This can include rain, snow, fog, hail, or even dust that is acidic. Acid rain results when sulfur dioxide and nitrogen oxides are emitted into the atmosphere and transported by wind and air currents. The SO2 and nitrous oxides react with water, oxygen, and other chemicals to form sulfuric and nitric acids. These then mix with water and other materials before falling to the ground. While a small portion of the SO2 and nitrous oxides that cause acid rain is from natural sources such as volcanoes, most of it comes from the burning of fossil fuels. Major sources of SO2 and nitrous oxides in the atmosphere include burning of fossil fuels to generate electricity, vehicles and heavy equipment, manufacturing, oil refinery, and other industries. So this is the other thing that's kind of missing with that. If you start injecting unnaturally an awful lot of sulfur dioxide into the atmosphere, it is eventually going to have to fall out somewhere, just as it would if there was a volcanic eruption. And so this is the kind of thing where it gets a little squirrely, because what are you going to do? Because that does have pretty profound negative impacts on ecosystems and on agriculture and the like. Caldera and others say SRM should be pursued with extreme caution, if at all. It could noticeably whiten our blue sky. It could whiten being a reflectivity thing. When they're talking about that, they're talking about reflectivity. It could weaken the stratospheric ozone layer that protects us and Earth's biosphere from ultraviolet radiation. This is another thing you have to recognize. In our stratosphere, we have the ozone layer. The ozone layer is the reason why when you walk outside, you don't get sunburned horrifically bad within 5 minutes. It actually catches the most dangerous types of solar radiation and prevents that from coming to the Earth's surface. So messing around with the ozone layer would be a bad thing. It might change weather patterns and move monsoons that water crops for billions of people, and it wouldn't do anything to remedy other CO2-related problems such as ocean acidification, which is harming the ability of corals, shellfish, and some plankton to form skeletons and shells. So ocean acidification, what this is basically, just as you are things that put CO2 into the atmosphere, you do have things that take CO2 out of the atmosphere, and the ocean is one of them. But putting a tremendous amount of CO2 into the atmosphere at one point does also cause a lot of carbonic acid to form. And so that's what they're talking about with ocean acidification, is that the natural process reacting to the amount of CO2 in the atmosphere is trying to take it out of the atmosphere, and therefore it becomes more acidic as it has as it has a acid, making an acid essentially. I don't remember exactly what the name of the acid is. Off the top of my head, it's escaping me, which is terrible. What is that name? I forget. Yes, when CO2 is absorbed into seawater, a series of chemical reactions occur, resulting in the increased concentration of hydrogen ions. This increase causes the seawater to become more acidic and causes carbonate ions to become relatively less abundant. Carbonate ions are an important building block of structures such as seashells and coral skeletons. Decreases in carbonate ions can make building and maintaining shells and other calcium carbonate structures difficult for calcifying organisms such as oysters, clams, sea urchins, shallow water corals, deep sea corals, and calcareous plankton. That changes in ocean chemistry. Yep, okay. That's just more to the point here of what they're talking about with ocean acidification. It's escaping me the name of the exact acid that's made, but it does become more acidic because you're just getting more hydrogen ions in there. Critics also say that the very idea of an escape hatch such as SRM could undermine support for reducing greenhouse gas emissions. Like a prescription drug, if SRM were used responsibly, temporarily, and in small doses, it could be beneficial, easing what is likely to be a dangerously hot century or two and buying humanity some extra time to transition to renewable energy. But it also has potential for abuse. At higher doses, it could increasingly distort the climate, altering weather patterns in ways that pit nation against nation, possibly leading to war. So, for all these reasons, more than 400 scientists have signed an open letter urging governments worldwide to ban SRM experiments. But other scientists are proceeding, if reluctantly. Quote, all the scientists I know are working on this. None of them want to be working on it, says Alan Roebuck, climatologist at Rutgers University. Roebuck, who previously showed the world how nuclear winter could shroud Earth, studies SRM out of a sense of obligation. Quote, if somebody's tempted to do this in the future, he says, they should know what the consequences would be. And I mean, that is fair. That is a fair thing to ask. You know, what are the consequences if we tried to do something like that? Now, barring actually doing that with the planet itself in real time, the next best thing to get around that is most likely the modeling world, computer modeling world, but these kinds of things to the best of our available ability. Forget how long this thing is. Wow, this is a long sucker. Hopefully get all the way through this, but I don't know off the top of my head. Experts who support trials note that unabated warming is just as consequential. In a recent report, the World Meteorological Organization estimated a 66% chance that by 2027, the world's average temperature would briefly exceed 1.5 degrees Celsius above pre-industrial levels, a dangerous threshold beyond which extreme damage to the environment occurs. Might be more appropriate to say is believed to occur, or will occur, or may occur, or is projected to occur, might be the better way to say it. On February 27th, 2023, a few days after Eisenman and Song sent barbecued sulfur into the sky, 110 climate scientists, including pioneer James Hansen, published an open letter urging government support for SRM research. Oh boy. And in June, the Biden administration released a report outlining what SRM research program could look like. Even if SRM reduced average temperatures, it wouldn't reset the climate to its pre-industrial state, says David Keith, head of systems engineering at the University of Chicago, who has studied the idea for over 2 decades, but it could lessen the hurt coming for us. The idea that humans can change the planet's atmosphere for their own purposes has a long history. In 1962, the U.S. military started Project Storm Fury, an attempt to weaken hurricanes by seeding clouds with silver iodide particles. From 1967 to 1972, the U.S. Air Force dabbled in weather control warfare over Vietnam and Laos in a highly classified effort called Operation Popeye. Several aircraft flew daily missions to spray lead and silver iodide powder into monsoon clouds. The goal was to increase rainfall, which would muddy up the Ho Chi Minh Trail, a network of coarse roads, interrupting Viet Cong supply lines. As soon as scientists understood that rising CO2 could warm the planet, some of them proposed making Earth more reflective to counter the effect. In 1965, scientists reported to President Lyndon B. Johnson that warming caused by rising CO2 could be addressed by spreading reflective particles across the oceans. In 1974, Russian climatologist Mikhail Budiko suggested that injecting sulfur dioxide into the atmosphere via aircraft or rockets could reflect sunlight. This technology, he wrote, should be developed without delay. Perhaps surprisingly, these proposals did not include the idea of reducing emissions. So, this is more so of a history kind of thing here, which, from what I can read, is actually a pretty good bit of history. It doesn't change the current concern here, and this is actually a pretty good example of some of the ideas with this, in that, for one thing, you can just have aerosols that reflect light and inject them in here. You can have clouds that get thinned out with silver iodide particles, enlarging ice crystals, allowing more heat to escape from Earth. And at the same time, making clouds just brighter in general is actually another way to do it, because generally, the brighter the cloud, the more reflective something is, the higher its albedo is. And this is actually the stratospheric aerosol injection that they're talking about here is what they're talking about oftentimes with the SO2 particles, and it is most well known with this. So stratospheric aerosol injection is the best studied approach to solar geoengineering and the closest to deployment, but making it work would require overcoming major challenges. The atmosphere, 20 kilometers up, is neither Earth-like nor space-like. At that altitude, roughly twice as high as commercial jets fly, the air pressure is just 5% of what we enjoy on the ground, low enough to spontaneously boil the fluids out of a person's mouth and lungs. Lift against an airplane's wing is minuscule. Only a handful of research planes worldwide can operate in air this thin. The best known is NASA's ER-2, a derivative of the U-2 spy plane with a tiny fuselage and gangly oversized wings. It is piloted by a single human who must wear a full pressure suit like an astronaut. It carries less than 2 metric tons of cargo. So this is the other thing. Logistically, it's an immense challenge to do that kind of stratospheric aerosol injection, just because it's going to be really hard to protect yourself from the differential in air pressure. You don't have a lot to breathe, and if something goes wrong and you're not pressurized, you're dead. And at the same time, it's not entirely space-like either. So it's you're hitting that transition point where so much of the Earth's atmosphere is actually below you that you're running out of things to work with, and planes themselves can't fly. Now, of course, you have the shuttle, but the shuttle goes out farther than that, and space shuttles go out further than that. So you have to have some kind of technology there in the middle to actually fly in that kind of thing, and there are very, very few planes that can do that, very few rockets that can do that. Let's see. The idea being, of course, you could eventually develop said planes with existing technology. Building a fleet could take 20 years, though. And yeah. Depending on how much SRM is desired, Smith envisions 90 to 900 planes flying missions every day by 2100. Building the first plane might take 7 to 10 years. Building a fleet could take 20 years. That's where you get to the problem. You're right back to the same problem. Is the amount of time sometimes to pull these things together is a huge challenge. Smith estimates that once the planes are built, the program might cost $18 billion annually per degree C of cooling. It's just a small amount compared to the hundreds of billions of dollars a year it would take to remove billions of tons of CO2 from the atmosphere. But SRM has much higher chance of carbon removal much higher chance than carbon removal of causing nightmarish unintended consequences. Stratospheric injections by any country would affect the entire globe. Done wrong, they could disrupt weather patterns and the lives of billions of people. A large fraction of humanity depends upon a belt of thunderstorms and rain called the Intertropical Convergence Zone. Yes. Okay. Right in here where you have those particular trade winds come in, and it doesn't stay in exactly the same place. It goes up and wiggles down depending upon the season, because seasonality does have a big effect on it. But one of the reasons you get so concerned about stratospheric injection of aerosols is potentially interrupting something like that. Why? Because the Intertropical Convergence Zone does have a lot to do with monsoons. And monsoons are a primary source of water in seasonality, in seasonal cycles for many different parts of the world needed to grow food. So, again, do you really want to mess with it? In 2008, Bala, the scientist at Livermore who first tested SRM in a model, moved to the Indian Institute of Science in Bangalore and began to study how human activities might affect that country's monsoons. His simulations showed that if monsoons were ejected at the equator, if aerosols were ejected at the equator, they would spread over the northern and southern hemispheres with little impact on monsoon patterns. But some people have proposed a polar strategy in which aerosols could be injected at high northern latitudes and slow rapid Arctic warming without overcooling the tropics. This well-intentioned proposal would have a huge impact on Indian monsoons, Bala says. His calculations, published in 2022, suggest that if injections sufficient to cool the planet by 1.5 degrees Celsius were done at 30 degrees north, the monsoon band would shift southward by roughly 150 kilometers. reducing India's summer rainfall by 29%, up to 29%, and threatening crops. This is the thing. This is why you can't just do it one place and expect it to not have profound impacts, because you're putting stuff into the atmosphere that high, it moves everywhere. It goes everywhere at that point. And it can rain out somewhere else eventually, because eventually all these particles that you're throwing into the atmosphere, random little particles like that, they don't necessarily just stay up there forever. They either, in chemical reaction, are removed, or they get rained out, and that's the issue with acid rain. But yeah, so there's a tremendous amount of risk. There's a tremendous amount of risk with this. This is a really long article, actually. I didn't realize it was as long as this. People who support SRM point to studies showing that it could affordably reduce climate extremes. Critics point to studies showing the havoc it could cause. But the scientists who try to forecast effects will admit that most of these predictions contain huge uncertainties. The uncertainty begins with the models being used. Although SRM has shown consistent results in more than a dozen climate models, that's not because widely varied approaches are converging on the same answers. It's because we have too many people running climate models that are similar. If assumptions underlying one model are wrong, they might all be wrong. Distinctly possible. To address this uncertainty, Keith recommends running large ensembles, hundreds of different versions of the same models, in which different combinations of numbers are plugged in. Scientists have done only a few such studies of SRM effects. Keith hopes to oversee more ensemble work at the University of Chicago. The range of climate outcomes this research produces could then be plugged into models and predict how SRM could affect crop yields, forest fires, storms, and the spread of malaria and other diseases. Still, no matter how many large ensembles scientists run, it is impossible to know how SRM will work until it's been tested in the real world, and tested at much larger scale than two guys releasing a balloon outside Reno. And this goes right back to the problem question. Do you really want to screw around with things? Do you really want to do that? This is actually a really high stakes thing, because you do have, you could potentially reduce the amount of warming coming from greenhouse gases, yes. With it, you could also have the very flip side here. So one thing I'm getting, and I will say this with this article, is that it is actually fairly balanced regarding the issue of the issues with geoengineering in general, in that you can end up with, holy crumbly, lots of problems with doing geoengineering. And I go back to the geopolitical one as being the biggest thing. Who controls the thermostat? Because you cannot just put, when you're talking about altering Earth's energy budget altogether, in that kind of very direct and manipulative fashion, you cannot just say, oh, okay, we're going to do it for our country, because it will inadvertently have an effect. You start putting stuff that high into the stratosphere, it goes everywhere. We know this with volcanic eruptions. For sure. That's a very natural way to do it, and starting to do it artificially on a regular basis, well, that's a whole other thing. Many SRM opponents would like to ban experiments outright, yet some scientists are continuing the research because they believe it's the responsible thing to do. The people who should be advocating for experiments the most are the people who think that bad stuff would happen, Caldera said. The most valuable experiment that somebody could do now is one showing there would be really horrible consequences. And if SRM is going to be studied and perhaps even rolled out, it's better to start sooner and more gradually, so the downsides can be understood. Ironically, SRM might have more public support if it were delayed until climate impacts become extreme. But at that point, it would have to be done urgently and rapidly. There's a real mismatch between what's politically and environmentally risky. So I don't like that an immediate kind of thing, because it points to manipulating people, which I'm just generally not for. Even small experiments will need the legitimacy of being funded and regulated by the government, Kelly Wanzer says. She is executive director of Silver Lining, a nonprofit organization that is encouraging the National Science Foundation and other government bodies to establish funding for SRM research and set up rules defining how and when experiments can be performed. Scientists would like that kind of governance, Rick says. After all, it has long existed for sensitive science areas, such as medical studies in humans, and has improved the quality of that research. The goal would be an international body, similar to the Intergovernmental Panel on Climate Change, that would set research priorities while considering the interests of rich and poor nations. Absence that structure, legitimate science is not progressing, Rick says, and rogue activities are starting to emerge. 2 months after the Reno balloon release on April 10th, Eisman and Song visited the Berkeley Marina in California to launch 3 more stratospheric balloons, funded by $2,840 cooling credits purchased by customers. A747 emits this amount in a couple of minutes, Eisman said as he held high the first balloon in his right hand, with San Francisco Bay shimmering in the background and camera crew filming. Then he let it go. A few days later, the 2 men attended an Earth Day event in San Francisco where they helped children launch their own small balloons coated with chalk dust, which could aerosolize. Our goal is to make 1,000 new geoengineers. Okay. So I gotta say, this article is very balanced. I actually really appreciate that coming from Scientific American. I don't appreciate the manipulative side of it. This is not so much about the science, though that's certainly wrapped up in there, as it is about the political sort of tugs of war, do you do it, do you not, kind of thing, which I can appreciate. I can understand that. It does have a good discussion of the scientific history in here, and I didn't get into that today just for a bit of brevity, but I do think overall this is actually a very half-decent article covering a very complicated topic. Now, one point that I want to make with this is that I, generally speaking, am not a big fan of the idea of geoengineering, just because of the whole geopolitical thing that would stir up. In that you got to figure out who's going to control the thermostat and how, because you can't really do it, and I don't think you really can do it in small controlled experiments everywhere at once and things like that. And what's going to happen if you do that and then something goes wrong and there's an effect you don't foresee? Who's accountable for that? Now, a lot of that may be set up by managing bodies and what have you, but generally, no. The other, so overall, I call this article actually fairly balanced. The hyperbolic, quasi hyperbolic subtitle notwithstanding. But I encourage you to read it. Let me know what you think. Brief review here of what is actually a half decent article from Scientific American. This is better than a lot of the other stuff that I reviewed from their section. But let me know what you think. Hit the like button on the way at the door, comment on the video, share the video, subscribe to the channel, all that lovely good jazz. Until next time, I'm Adrian. May you stick curious, everybody.